Hi everybody, good evening. Today I want to explain Semiconductor Devices Part-2. That means forward bias, reverse bias of PN junction diode, Zener diode, VI characteristic curves, and half wave and full wave rectifiers. So now, forward bias. If positive terminal of the battery connected to the P side and negative terminal of the battery connected to the N side of PN junction diode, then the diode is said to be forward bias. In forward bias, depletion layer width decreases. Why? Because in forward bias, the holes are repelled by the positive terminal and reaches to the junction. Electrons are repelled by the negative terminal and reaches to the junction here. There the depletion layer width decreases and current flows through the diode. The resistance of the diode in forward bias is very less. So, which of the following is connected in forward bias? They are asking in the NEET exam, 100% one question will come in these figures. So, if you want to connect a diode in forward bias, P side high potential should be connected, N side low potential should be connected. See, these are all diodes are connected in forward bias. If both are positive potential, high potential should be connected on P side and low potential should be connected on N side. If both are negative potential, low negative on P side and high negative on N side. If N terminal is connected to ground, it is zero voltage, then P must be at high potential, so positive potential should be connected. If P terminal is connected to ground, that is zero potential, that means it is high, let it be, the N should be low, that means you have to connect the negative potential to the N side, negative potential to the N side. Next, yeah, reverse bias. So P side connected to the negative terminal of the battery, N side connected to the positive terminal of the battery, junction diode is said to be connected in reverse bias. What happened in reverse bias? The holes are attracted by the negative terminal, the electrons are attracted by the positive terminal. There the depletion layer width increases, current doesn't flow through the diode. So the resistance of the diode in reverse bias is very large. So, which of the following is connected in reverse bias? 100% one question is coming in these diagrams actually. So, for reverse bias of PN junction diode, P side connected to low potential and high side, N side connected to high potential. So, see, both are positive potentials, P side connected to low potential and N side connected to high potential. Both are negative, high negative on P side, low negative on N side. If N side is grounded, that is zero potential, it must be P side low potential, that negative terminal is connected to P. If P side is connected to ground, so zero potential and N side should be connected to high potential, that is a positive potential. So this is about the reverse bias. So VI characteristic curve of a PN junction diode. See here. So voltage and current, VI means voltage and current characteristic curve of a PN junction diode. Here VB in the figure shown is breakdown voltage. What is the breakdown? Covalent bonds break, that is called breakdown voltage. Slope of VI graph gives I by V, that is reciprocal of the resistance, maybe conductance. Tan theta is equal to I by V, that is equal to 1 by R. See, this is forward bias curve. This is the forward bias curve. So up to some extent, the current doesn't rise. That voltage is called knee voltage in the forward bias. Knee voltage means that is the potential barrier. In case of germanium, the potential barrier is 0.3. In case of silicon, the potential barrier is 0.7. So in the reverse bias, a very low current will pass through the diode due to minority charge carriers. Very low current will pass through the diode due to minority charge carriers. At certain reverse voltage, the covalent bonds will get break and abnormal current will flow through the diode and diode will get damage in the reverse bias. So abnormal current means a flood of electrons will flow, that is called avalanche breakdown. Both side junctions are lightly doped in normal diode. So why avalanche breakdown occurs? Because both side junctions are lightly doped, depletion layer is large, electric field across the junction is not strong. So that's why avalanche breakdown occurs in the reverse bias. What is the GNR breakdown? GNR breakdown means the diode is made with very thin junction. Both sides are heavily doped. Depletion layer is narrow. Electric field is strong enough to break covalent bonds. So that's why it is at GNR breakdown, the diode will not get damaged. At avalanche breakdown, the diode will get damaged. This is the VI characteristic curve of a junction diode. VI characteristic curve of a junction diode. Next, what is Zener diode? Heavily doped PN junction diode is called Zener diode, operated in reverse bias at breakdown region. In reverse bias, it acts as a voltage regulator. In forward bias, the Zener diode will act as a normal diode. So see, this is the Zener diode operated in reverse bias. That means this circuit is voltage regulator circuit. Here it is input voltage. Here it is called series resistance. This is Zener diode connected in reverse bias. Zener diode connected in reverse bias, and a load resistance is connected here. So output can be drawn from the load resistance. Here these four formulas are very much important for doing the problems in a Zener diode. Here this Zener diode and load resistance, they are connected in parallel. That's why the voltage across the Zener and the voltage across the load will be same. Therefore VZ is equal to VO, output voltage. What is the main current flowing through the Zener diode from the source? So V in minus V0 by Rs, that is the main current. So here the current I divides into two, Iz and IL. See here, Zener current and load current. What is the load current? Load current is output resistance by load resistance, or Zener voltage by load resistance. So what is the Zener current here? Zener current Iz is equal to, from this equation, I minus IL. That means V in minus V0 by Rs minus V0 by RL. So this is about the Zener diode, and recently on Zener diode the questions was given. Now junction diode as a rectifier. The device used to convert an alternating current into a direct current is called rectifier. PN junction diode can be used as a rectifier because it permits current in one direction only. So see, this is half wave and full wave rectifiers. A single diode is used as an half wave rectifier. See that single diode is used as an half wave rectifier. This is a transformer. This is input AC voltage. This is output DC voltage. The efficiency of the full wave half wave rectifier 0.406 RL by RF plus RL. RF is diode forward resistance. Full wave rectifier, two diodes used as full wave rectifier, D1 and D2. Here you will use a transformer which is called center trap transformer. Center trap, it divides the potential. When D1 is positive, D2 will be negative. When D1 is negative, D2 will be positive. So any one diode will get forward bias during the AC cycle. So the efficiency is double the half wave rectifier, 0.812 RL by RF plus RL. RL is called a load resistance. If F is the frequency of the input signal, frequency of DC output signal is F in case of half wave rectifier. So many times this question was given. so many. In the numerals they given, if it is 50, this is also 50. If F is the frequency of AC input signal, 2F is the frequency of DC output signal. Very important for full wave rectifier. Double the frequency, full wave rectifier. See, this is the AC input of half wave rectifier. So this is a DC output. This is AC input. This is the DC output of half wave rectifier. So negative will not be forwarded here. So here it is positive, negative. Any one of the diode will be in the forward bias. Therefore, D1, a D2, a D1 like that. So this is the a full wave rectifier. So thank you very much. Try to read these all the concepts what I taught now. So very important semiconductor devices. 4 questions you will get in the semiconductor devices, and I have to teach. I have to explain only gates. In the next session, I will explain the gates. Have a nice day. So try to subscribe this channel so that more and more concepts I will teach, and it is very benefit to the students who are attending the NEET Re-NEET 2026, which going to be conducted on June 21st. Thank you. Thank you very much.